All right, let's check out this substitution. So when I see something like this, that there's two things being multiplied and there's a power, I know I need to substitute something. So I always look to substitute what is inside something. Now, as you continue to work these, you will notice what u is always, if it's a power, one power higher than the outside, or the derivative, I should say, is going to be the outside. And what I mean by that, when I write du, that says take the derivative of this, where you bring the 4 down, you subtract 1. Of course, the minus 1 is a constant, so the derivative of a constant goes away. And then you write dt. And then what you notice is the outside doesn't have a 4. So that's where I divide the 4 off both sides, and I get this now matches exactly this outside, and that's what you want it to do. So now you just substitute back. So in this case, the substitution will be 1/4, and I'll throw that out front, du, where now this inside just becomes u squared. And now this is kind of the whole point of why you do this, is now this is easy to take an antiderivative, because that would be u to the 2 plus 1 over 2 plus 1, which would be u to the 3rd over 12. And then your last step, you plug back in what u was, which is t to the 4th minus 1 cubed over 12. And then just don't forget your plus c. But that's the whole point of doing these, is you want to have something where you can find the antiderivative very, very quickly, and you certainly can't do that with this first part. All right, let's look at this next one. So the next one basically says use this function and find the general antiderivative. So in other words, that says do this, 9x cubed cosine x to the 4th. Now I know x to the 4th is going to be my u. Why? Because that's my du is 1 power less. So over here, I'm going to say let u equal x to the 4th. What's the derivative of x to the 4th? 4x cubed dx. The problem is there's a 9. There's not a 4 over here. So I divide the 4 off again, and I get x to the 3rd dx. And notice here now, you know, students always say, well, what do I do with the 9? Don't do anything with it. Just put it out front. This is where I will say a lot of times you might want to rewrite the order. So I'm going to just rewrite this problem again. But notice I rewrote the order because now I can see that is exactly x cubed to the dx. So that piece becomes the 1/4 du. And I can put the 1/4 out front, right? 1/4 times 9. And now I have cosine u du. Convince yourself, 1/4. There's the 1/4 piece right there. There's the du. And now when I take the antiderivative, I get 9/4 sine, and then finally I plug back in my u to get my final answer. And I know that one was probably a little fast, but it's getting you to the point where you can see, first of all, to see easily what the u is always going to be 1 power less. All right, now this is doing kind of the same thing, but now this is an FTC, meaning that I have my A and B. So I know I'm going to have to do the f of B minus f of A. Once again, what do I think u would be? Why do I think that would be u? Because the derivative of u is going to be, get this written down, the derivative of sine is cosine. And look how that's exactly the outside. So I can rewrite this 3 pi, what's that, 5 pi over 2. I can rewrite this as e to the u, because that's my sine, and where you see cosine q dq, that's what I like about Texas. You put that. What's the antiderivative of e to the u? I think it's just e to the u. And I'll do it. Well, I'm going to go ahead and plug it in. So the antiderivative of e to the u is e to the u. And now I plug in this. Okay, so this is the antiderivative. And finally, I'm going to plug in 3 pi and 5 pi over 2. If you do not remember your unit circle, that's fine. You can pick up a calculator. So 3 pi minus e to the sine of 5 pi over 2. If you just pick up a calculator and you put sine of 3 pi, you will see that this piece is 0, so that's e to the 0. And then if you put sine of 5 pi over 2, you will see that this, so that piece was 0. You will see this piece is 1, so you actually get that, which finally the final answer, just 1 minus e. You can put this all in your calculator and get an actual decimal, that is fine, but just showing, because some of y'all are like, why isn't it counting it right? It's not, because it's not telling me how to round, because it wanted an exact answer was the reason why. All right, now this last one might confuse you a little bit because you might wonder, why is this in substitution? Some books actually say, like the, you know, the e to the kt, they say to use substitution, where they say let u equal the negative 0.08t. I don't do it that way because I have taught you guys that you can do the 1 over k thing, right? You kind of sort of remember that, hopefully. But before we get to that, so it says this is a rate. So at what rate in thousands of liters is the oil leaking out at t equals 0? That just simply means plug in 0. 0.8 times 0 and 30 e to the 0, which is 30. And that's how we get 30 there. And then the second one, just simply plug in 60. But now this is the part that I was saying that, again, you might wonder, why is this in this section? Because we're not actually doing the substitution method, because you don't have to. You can use the, let me get this, negative 0.08t. You can use the 1 over k, so negative 0.08, and then this just stays the same. And just read this carefully. This is in minutes, so you want to do 0 to 60, and I will leave that one for you to finish up and solve. And that's all, folks. That's all for this homework.